Hi everyone, in today's lesson we're going to continue graphing hyperbolas. This time we're going to focus on hyperbolas where the center is not at the origin. So these two pictures are exactly the same except this center is not x is 0, y is 0. So just a couple of things. Hyperbolas have branches. The foci lie inside the branches. And the vertex are where these parabolas start, right? They start here or here and here and here. And the all those values lie on the transverse axis, where the conjugate axis is the b value. And the b value is just the distance that helps us make the box. So when we go corner to corner to make our asymptotes, we have the ability to do so. So we have a different formula when the center is not at the origin. So in order to get a horizontal hyperbola, you need to have the x squared to come first. The a squared and b squared never change. They're always staying in that same spot. Look at the formula here, a squared, b squared. They're not changing like ellipses, but what's changing is the x and y. So the x comes first here, but the y comes first here. So to get a vertical hyperbola, the y has to come first. To get a horizontal hyperbola, the x has to come first. Okay? And A is always the distance from the center to one of the vertices, and B is always the distance from the center to the box, right? Center to the box. And here's how you could calculate the asymptote equation, but we're going to do it without that moving forward, so you can keep that as a reference. All right, let's try to graph one. But I actually noticed that this example goes off this current graph, so I'd actually like to change this to say x minus 1 squared, and then I'd like to make this one y minus 1 squared as well. So let's analyze this. We see that the x comes first. Therefore, we're going to have a horizontal hyperbola. And why? Because the x squared term comes first. So helpful to write that down for sure. And now we can analyze the center. So the x value of the center will go with the x term, so it's positive. Remember, we're switching the signs, so it'll be a positive 1. And the y value of the center will be the opposite of this sign here, which is negative 1, so positive 1 as well. Now remember, the bottom numbers never change. The 1 is the a squared, and the 49 is the b squared. So that means the square root of 1 is 1 for A, and the square root of 49 is 7 for B. So now that we have that information, we can go ahead and graph it, and we can calculate our vertices and then our foci. So my center is at the point 1, 1. Now, since we have a horizontal hyperbola, we're going to go right 1 and left 1 of our A value. A gives us the vertex, right? But we're going left and right. So we can label this V1 and V2. Doesn't matter which one you label which. And then now to find the B value, we're going to go up 7. So we're going to go all the way up here, and then we're going to go down 7 about here. And we're going to connect, and we'll make our box. And this is the box that's going to help us create our hyperbola. So the vertices look like we have a point at 0, 1 and 2, 1. So we can go ahead and label that 2, 1 and 0, 1. And to find the coordinates of our foci, we need to use the equation c squared equals a squared plus b squared. We know that a squared is 1 and b squared is 49. So we have c squared equals 1 plus 49, which gives us 50. And to calculate c, we're going to take the square root of 50, which can be simplified to square root of 25 and the square root of 2. So the square root of 25 is 5, and 5 rad 2. Now, in order to graph this, we really need to know what the decimal equivalent is to 5 rad 2. So if you type that into the calculator, you will get a value about 7.07, something along those lines. Obviously, there are more decimals, but that's the estimate. So what are we going to do to graph our foci? We're going to go right 7.07 and left 7.07, but from this center point. So 1, 2, 3, 4, 5, 6, 7, and a little bit. It's okay that it goes off. and we'll label this foci 1. And now we're going to go left from the center. 1, 2, 3, 4, 5, 6, 7, and a little bit. And that's going to go there. And we can label that foci 2. And remember, to find the coordinates of the foci, what did we do? We're at an x value of 1, and we subtracted 5 radical 2, or 7.07. So that's our x value. Our x value is 1 minus 5 rad 2, comma, your y value never changed, your y value is 1. And then to get our other foci value, we start at an x value of 1 and we add 5 rad 2. So my x value is 1 plus 5 rad 2. And again, my y value hasn't changed. Y value is still 1. So last but not least is our equation of our asymptotes. And if you remember, the asymptotes are the lines that go from corner to corner. So remember that asymptotes are dotted because they're not actually part of the hyperbola. So we're going to go through the center, and those would be my asymptotes. You may want to extend them a little bit. And then from this corner down to my center, down to my other corner, again, you may want to extend it out a little bit. Extend it out here on both sides. So if I'm going to graph my hyperbola now, we always graph the hyperbola from the vertex. So my vertex is here and here. So we're going to start the graph here, and we're going to go towards the hyperbola or the asymptote this way, asymptote this way, and this way. And that is my horizontal hyperbola. I know it's weird. It's stretched out a lot because that this value was 7. It definitely would have looked cleaner had the b value be a little bit smaller. But if I want to write the equations of these asymptotes, remember point slope form. So remember we have y minus y1 equals m x minus x1, where m is your slope and x1, y1 is the point on the line, or any point on the line. So we can leave them in these form. I'm okay with that. So let's look at this one first. We'll call this line 1, and we'll call this one line 2. So line 1, it doesn't matter which point you choose. You can go through this point, or this point. I'm going to choose the center because it's also part of line 2. So when I'm making the equation, I'm going to make my x1, y1 my center point, which is 1, 1. So when I put it into the equation, it's y minus 1 equals a slope x minus 1. And I can do that for the other equation as well. And all we will need is just our slope. So take a look. Slope is rise over run. So if you start at the center, how many are you going up? 7. How many are you running? 1. So positive 7, right 1, is a slope of 7, or 7 over 1 if you want to leave it like that. How about this line going negatively? We're going down 7, right 1. So down 7 would be negative 7, right 1 would be positive. And if you just want to make them nice and simple, it would be y minus 1 equals 7 times x minus 1, and y minus 1 equals negative 7 times x minus 1. And those would be your equations of your asymptotes. All right, let's take a look at example number 2. I'm going to get you started on this one, and then you guys will finish this one on your own. I did notice again that this one goes off the graph a little bit, so I'd like you to actually change this top values to be x minus 2 squared, and then I'd like you to change this to be y plus 1 squared. And then I think it should be a little bit easier for you guys to graph. But everything stays the same. The 25 is still my a squared. The 9 is still my b squared. This time we have a vertical hyperbola. And the reason why we have a vertical one is because the y value comes first, right? So if you want to write that down, that wouldn't be a bad idea because y squared comes first. Now, the tricky part that people might get confused is the center. So notice the center point is always x comma y, right? So you have to be careful not to make this your x. The x is attached over here. So the center is actually positive 2 from there, and then the positive one changes to a negative 1, and then that is your center. So it's based off of x, then y. So just be real careful about that. All right, I think you guys can actually try the rest of this one on your own and then hit resume when you're ready for your answers. Okay, here they are. All right, as you're taking a look at these answers, a couple things that I just want to discuss are the coordinates of the foci. This is the probably most confusing part, but notice the foci are all in line with this x value of 2. So notice my point is 2 comma something, 2 comma something. So that x value is not changing. We're just adding radical 34 to get up here, and we're subtracting radical 34 to get down there. So that's how I got my 1 plus rad 34 and negative 1 minus rad 34. A couple of things about the equation of the asymptotes. Your slope is your rise over your run. So for this positive slope, I'm rising 5, running 3. Therefore, my slope is 5/3. For this one, I'm falling 5 and running 3. So oh, I think I did this backwards. I'm sorry about that. This should be negative 5 over 3. I'm falling 5, running 3, right, for this equation. And then the center point, both of this asymptotes contain this point, which is the center, 2, negative 1. So I just made that my x1, y1. So y minus a negative 1 is plus 1, and x minus x1 of 2 gives me 2. All right, I know there's a lot here, so please jot down any questions that you have at this point, and we'll touch base in class tomorrow. All right, have a good night.